Let's say if you're working on an application and it works fine in local, but when you take it to prod, it also works fine for a little bit, and then the user come to your desk pounding, "Hey, this is not working," and some other user comes to your desk asking, "Hey, why this is not working?" Then what you would end up doing is like you rush to your developers and ask them to check the logs, and then you take a little bit of time digging into what actually happened, and they come back to you, and then you respond back to the users. But what if we could know what the issue is beforehand, and when the user come knocking at your door, you tell them, "Hey, hi user, and we know why you are here, and this is what actually happened." It might not make the user's life better, but at least they might have a little bit confidence in what you are doing, isn't it? So if you are looking at how we are gonna do that, that's what we are gonna look into today's video. Without any further ado, let's get started. In both these cases, you just see a thin line of difference between how you monitor stuff and how observability works. In an ideal world, you keep observing for the issues that the user hasn't reported, but you are foreseeing it for the user's good, and for your good by using some tools. So when it comes to tools, the first thing that you would hear people talking about is like instrumentation, and then now you would go, what the heck is instrumentation, isn't it? Don't be scared, it's straightforward and easy to understand. Instrumentation is nothing but making code changes or configuration changes or changes to your application such that your application is able to emit certain data points which you can use to further visualize or observe things that are part of your application. It could be a technical standpoint on amount of RAM that you use, or it could be the amount of processes, or it could be also a custom metric from your application that could help you track, see how many orders been placed, or like say if the customer is just adding things to your cart but like they are not proceeding to the payment gateway. So you can figure out like all those stuff using those set of metrics. Now we know that there are a lot of data points involved. What are these actual data points talking about? What would they be like? So they could be logs, wherein when a user comes to you asking, "I have an issue," so you grab their user ID and the timestamp of when that happened, and then you go into the logs searching for the keyword error or like the user name, if at all, if you had printed in the logs, and then probably narrowing down between the timestamp, you will be able to find an error stack. And when you see the error stack, you go check the class or actual error exception that has happened, or you would see the error class and then go back to your code and reference it just to make sure what would have happened. But assume that your application is these days are just not going to be a monolith where you're just interacting with one service. You might be interacting with multiple services, isn't it? Say if a customer comes to you saying that there was an issue placing the order, what actually might happen behind the scene is the order that they are trying to place might subtract the product from the inventory, which is running on a different service altogether, which the order service does not have an idea about, but like it invokes the inventory service or like the product service to get it deducted from the inventory. But if there is something wrong there, how would you be able to backtrack that? So that's where we would end up passing the trace ID as part of the thread local of the request that's trying to make the call. So this trace ID is going to travel back to the next service and so on, so and so forth, so that we would know what actually happened for the whole transaction across those distributed systems. Say if something has happened in the second server, then we will know that okay, so this is the error stack from the second server, and that's the reason the first thing didn't do well. So that sort of thing, right? And on top of that, as I mentioned earlier, with respect to the metrics, so you can go forth and figure out who hasn't proceeded to the checkout, right? So those are the metrics. So given that, like, these are the three main pillars of the observability, I would say. So the logs, metrics, and the traces. And at the same time, there are also a different sort of tools that you might have used in the past, like JFR provides profiling, isn't it? So wherein you could use a continuous profiler from the Java world. It is supposed to be probably you can use JMC mission control to visualize the profile. That will help you figure out the call stack and stuff like that, and also the flame graph to note. And does it stop there? It doesn't. So you have alerting, you have heartbeat synthetic monitoring, you have like a way to track your SSL validity expiry. You also have like alerting wherein when a certain threshold is met, you can set alerts, or like you can send emails to your email boxes that you wish. You can also track the user session where the user logged in, or like how many users are actively visiting your website, something that's similar to what Google Analytics gives you. In the world of AI, you also get a anomaly detection and stuff like that. Being said that, like next thing what we are going to take a look at is how do we do it. When it comes to instrumentation, like there are three big items that we need to understand how this thing work. So our application itself is like what needs to be instrumented, but once it gets instrumented, it's going to spit out some data points, and that needs to be saved somewhere, that we call as data backend. And then we also have a visualization tool which is gonna help use those data points and put some graph or like bar charts and stuff like that, so that we don't have to deal with number, rather we can see things happening in a pictorial representation. Now we understood most of the moving parts that are part of this observability platform. Right now, when it comes to a Spring Boot application, what choices do we have? First thing first, we have to think about instrumenting the application. When it comes to instrumenting the application, if at all, if you were to Google, the first thing that you would end up seeing is micrometer. Micrometer now becomes the standard for Spring Boot instrumentation. So earlier they were just for metrics, and then we had like sleuth. Now it's been combined together. So the sleuth is going to provide the trace ID and the span, wherein now since it got merged together into micrometer, now everything is bundled together. But when we look at like micrometer, it's not a single library. Right now we have like multiple libraries that you need to import as part of your dependency. Each one of them are for different use cases, which we will talk about it. So what this does is like this tries to stay within the application, or like together with the application, collecting the data points. Now we understand that like micrometer is what something that we need to do. Aren't there any other configuration that we need to do on the application side? If that's the question, probably it depends upon what kind of tools or tooling backend that we would use. That brings us to the data backend. So the data backend either could be a collector which collects the data and then stores them. When it comes to the data backend, there are a different variety of choices that we have. Few of them are paid, few of them are like open source. Say in the open source world, you can end up using Loki for logs, Tempo, Jaeger, or Zipkin for traces, or like Prometheus, say in case of you are doing metrics. And then you would end up seeing a visualization tool. So since these data points are collected, and then you would need to visualize them, isn't it? So you would use something like Elastic Kibana or Grafana to visualize it. But end of the day, when it comes to the paid tooling, you would have Dynatrace, Datadog. Grafana also has a paid version to it, so you can use any of those of your choice. But if you think about it, like even here you have like a lot of moving parts, isn't it? Wouldn't there be a standard or something that ties these things together? Because each of them might end up following different formats when they send these data points. If you think about it, that's where the OTel comes into the picture. When someone talks about OTel, there are different flavors of OTel. OTel could be a library that probably might bridge the trace from whatever you are using to the actual OTel format, that which is W3C's format. Or it could be a OTel collector as a service that could be running as a middleman, wherein the application would send the data points to the OTel collector, wherein that will store it there, and the visualization tool can read it from the OTel collector, acting as like a middleman broker. That's something that we would need to look into, if at all, if we are trying to either switch between these tooling options, or if you are trying to ship data between more than one or two backends. Hope this would have provided you a bird's eye view of how observability could be set up in your application or for your application. I wanted to make a local hosting part of it as part of this video, but unfortunately, given the length of the video, it has already taken more than 7 or 8 minutes. So I would put that video as part of the part 2 as a continuation of the same video. I will also have a Medium post corresponding to the same video, and the local hosting one attached to this for you to take or to refer to. Thanks for watching. See you in the next one.